On a clear night, when the air is cold and still, a person can tilt their head upward and see a dome of stars that seems infinite. This ancient act of looking skyward has always carried a question at its heart. What exactly are we looking at when we speak of the universe? The word sounds simple, almost obvious, yet behind it lies a concept so large and layered that even physicists hesitate before answering. For most of human history, the universe was whatever fit inside the human imagination. To the early philosophers of Greece, the universe was a finite dome of stars with the Earth at its unmoving center. The heavens were thought to be perfect and unchanging, a crystalline sphere turning around us. To the astronomers of the Middle Ages, the universe was an ordered hierarchy stretching upward to the throne of God. It was not until the age of Copernicus, Galileo, and Newton that the picture began to expand into something more familiar, though no less strange. The Earth became a planet circling a sun, which was itself just one star among many. Infinity crept into the imagination, and the word universe grew in meaning until it seemed to encompass everything. But what do we mean by everything? Even now, the definition slips away when pressed too tightly. In common language, the universe is all of space, all of time, and all of matter and energy contained within. It is not merely stars and galaxies, but also the voids between them. It is the quantum fields that ripple invisibly, the gravitational waves that pass unnoticed through our bodies, and the unseen scaffolding of dark matter. It is all that exists, yet even this answer hides complications. Modern physics draws a sharp distinction between what we can observe and what might lie beyond. The observable universe is a technical phrase that does not mean the same as the entire universe. Because the speed of light is finite, we can only see as far as light has had time to travel since the beginning. Our cosmic clock began some 13.8 billion years ago with the Big Bang. Light emitted in that first moment has been racing toward us ever since. However, space itself has been stretching, carrying galaxies away. The furthest distance we can currently observe is about 46 billion light years in every direction. This sphere around us is called the observable universe. It is vast beyond comprehension, yet it is still only a fraction of what might exist. Imagine being in a forest on a foggy morning. You can see the nearest trees, their trunks fading into mist. Beyond the fog, the forest continues, but your vision cannot pierce it. The observable universe is our cosmic clearing, the volume of space-time from which light has reached us. Beyond that horizon, the forest still grows, but no message from those regions has arrived. We cannot know if the forest has an edge or if it stretches forever. Astronomers describe this horizon with precision. They speak of the particle horizon, the maximum distance light has traveled since the Big Bang. They also distinguish the event horizon, the boundary beyond which events can never influence us, not even in the future. These concepts remind us that horizons are not physical walls, but limits set by the structure of space-time. When we say that a galaxy is beyond our horizon, we mean that light from it, no matter how long we wait, will never reach us. Expansion outruns even light. This truth unsettles our intuition. We are used to horizons on Earth that can be crossed with effort. A mountain blocks our view, but we can climb it. A sea obscures the shore, but a ship can sail across. The cosmic horizon is not like that. It is woven into the fabric of reality. No faster spaceship will ever change it. Even if we built engines that approach the speed of light, the horizon would recede faster still, forever keeping distant galaxies beyond reach. And yet, when we say universe, we usually do not mean only the observable portion. We mean the totality, the whole forest, whether or not we can see it. Physics admits that this larger universe may be infinite. It may continue outward without end, filled with galaxies forever beyond our sight. Or it may be finite but unbounded, a shape that curves back on itself the way the surface of a sphere does. Just as an ant walking on a balloon never encounters an edge, so might a traveler in space wander forever without finding a border. This idea is difficult because the human mind evolved to grasp finite landscapes. We expect walls, edges, endings, but the mathematics of general relativity suggests space can be both finite in volume and yet without boundary. When cosmologists speak of the universe in this sense, they are gesturing towards something larger than perception, something hinted at by equations but invisible to our eyes. The question then arises, if the universe truly includes everything, can it ever be said to have an outside? To leave the universe would seem to require stepping beyond existence itself. This is a paradox of language as much as physics. For if the universe is all that exists, then outside the universe there is by definition nothing. Not a void, not an emptiness into which one might fall, but the absence of existence altogether. This is the point where scientific definitions and human imagination collide. When we gaze upward on a winter night, what we are truly seeing is the history of light itself. Each star is a messenger from the past. Some photons began their journey before humanity existed. The faint afterglow of the Big Bang, known as the cosmic microwave background, is the oldest light of all, streaming toward us from a time when the universe was only 380,000 years old. To define the universe is to define a story written in light, a record of beginnings stretching back almost 14 billion years. Yet definitions are never enough. They give us boundaries to think within, but they do not satisfy the deeper curiosity. When a child asks, "Where does it all end?" the precise answer about horizons and curvature may not quiet the wonder. The child is asking something larger, something even physics struggles to address. They are asking whether there is a beyond to the beyond. To approach that question, we must first be honest about our own limits. The observable universe is as far as light has carried news to us. The entire universe is the greater whole we suspect but cannot measure. Between these two lies a gulf of mystery. To step into that gulf is to step out of science and into speculation. Yet speculation is often where progress begins. The horizon is not the end of the story, but its beginning. For once we recognize that our view is partial, we are compelled to ask what lies beyond. The definition of universe then becomes less a statement of certainty and more an invitation to exploration. It is not just a word for everything. It is a challenge to our imagination, a reminder that the cosmos is always larger than our grasp. And so, before we can ask if we might ever leave the universe, we must be clear about what we mean by the word itself. Are we speaking of the visible sphere of galaxies, bounded by the reach of light, or of the entire space-time continuum, whose size may be infinite, or of all possible realities, of which our own may be only one? Each meaning carries a different answer, each reveals a different horizon, and each opens the door to the deeper mystery that will carry us into the next part of this journey. The act of defining the universe is never a static task, for the universe is not a fixed object, but a living process unfolding in time. When we describe it, we are attempting to capture something that is always in motion, expanding, cooling, and evolving. The galaxies that shimmer faintly in the night sky are not frozen jewels set against a black canvas. They are moving away from us with the expansion of space, carrying with them stars that are born, shine for billions of years, and then die in explosions of light. To speak of the universe is therefore to speak of a changing story, not a finished structure. When Einstein introduced his theory of general relativity in the early 20th century, it became clear that space and time themselves could bend and stretch. Gravity was no longer understood as a mysterious, invisible force reaching across distance. Instead, it was revealed as the curvature of space-time. Mass and energy told space how to curve, and curved space told matter how to move. The implication was staggering. The universe itself could expand or contract. No longer was it a static stage upon which events played out. It was part of the play. This understanding reshaped our definition of the universe. The cosmos was not a rigid container, but a dynamic fabric. Observations soon confirmed this, beginning with Edwin Hubble in the 1920s, who saw that galaxies were rushing away from us. The further a galaxy, the faster its retreat. Space itself was stretching. The universe, it seemed, had a history of growth. If one ran the film backward, galaxies would appear closer together, denser, hotter, until they converged in an origin we now call the Big Bang. The Big Bang was not an explosion in space, but the expansion of space itself. There was no center, no blast wave pushing matter into emptiness. Instead, every region of space-time expanded simultaneously. This distinction matters deeply for how we define the universe. It means there was never an outside into which the universe grew. The universe was simply smaller in the past. If the universe is the sum of all space and time, then it has always contained all that exists, no matter how large or small its extent. Our instruments today allow us to peer astonishingly close to that beginning. Radio telescopes capture the faint cosmic microwave background, the cooled remnant of the fireball that once filled the cosmos. This ancient light is not merely a picture of the early universe, but a boundary to our seeing. Beyond it lies the opaque plasma of the first moments, when matter and light were fused together. We can describe those conditions mathematically, but we cannot see through them. Thus, even at the most fundamental level, our definition of the universe is shaped by horizons, by what can and cannot be revealed. The observable universe, then, is not arbitrary. It is carved out by the rules of physics. Its radius of 46 billion light-years is not a round figure drawn on a chart, but a real frontier written into space-time. It changes as the universe ages. New light arrives from previously unseen regions, and yet at the same time, expansion carries distant galaxies further beyond reach. The boundary is alive, shifting with the clock of cosmic time. To stand in this reality is to confront both awe and limitation. On the one hand, we live in a universe with more than 2 trillion galaxies inside the observable sphere, each containing hundreds of billions of stars. On the other hand, this richness is only the small fraction accessible to us. There may be infinitely more galaxies forever hidden beyond the horizon, their light destined never to reach our eyes. The universe, as we use the word in daily speech, is therefore twofold. It is the cosmos we can observe, measure, and describe with confidence. And it is also the unseen remainder, the part that reason and mathematics suggest, but observation cannot confirm. This dual definition creates a subtle philosophical problem. If science is grounded in measurement, then should we limit the term universe to only what can be observed? Or should we allow the word to include the unobservable as well? Physicists generally choose the latter, for the equations of relativity and quantum theory point insistently toward a reality larger than what light has carried to us. Yet it is important to acknowledge the leap involved. We cannot prove the existence of what lies beyond our horizon. We can only infer it. That inference is powerful. When we map the distribution of galaxies and measure the faint ripples in the cosmic microwave background, we find striking uniformity. On the larger scales, the cosmos looks the same in every direction. This symmetry strongly suggests that the universe continues beyond our view in a similar fashion. There is no sign of an edge, no abrupt cutoff. The universe seems vast and continuous, with no favored center. If the observable sphere is a patch of cosmic fabric, then the fabric stretches far beyond it. Perhaps it is endless. Yet our minds, trained by finite experiences, find it difficult to imagine endlessness. We crave a shape we can grasp, a container to hold the everything. Ancient myths often pictured the universe as a dome above a flat earth, or as an egg from which existence hatched. Even now, we are tempted to picture the universe as a giant bubble surrounded by emptiness. But the mathematics resists this picture. It tells us that if space is finite, it may curve back on itself without enclosing a larger void. And if it is infinite, then it has no edge to be found. The idea of an outside is meaningless within the framework of relativity. This does not mean the imagination must stop. Instead, it forces us to stretch our sense of reality. When we say the universe is everything, we must remember that this everything is not limited by our intuition. It is not required to have an edge or a beyond in the way a room does. It may be boundless in ways our language can only approximate. Our definition must therefore be both precise and humble. The universe is all space and time, all matter and energy, observable and unobservable. It is the totality of existence as described by physics. Beyond that, words stumble. And yet, even as we define it, a deeper tension remains. For if the universe truly is everything, then the idea of leaving it becomes paradoxical. How can one step outside of all that is? To pose this question is to push against the very limits of meaning. Perhaps we cannot answer it in literal terms, but by struggling with it, by asking whether an outside might exist, we open the door to deeper insights. The act of questioning enlarges our imagination, preparing us for possibilities that science may one day confront. Thus, the definition of the universe is not a final statement, but the first step of a journey. We begin by clarifying what we mean, distinguishing between the observable and the total, between what light has shown us and what equations suggest. From here, we will move to the subtler question of whether the universe has an edge at all, and if so, what kind of edge it might be. In doing so, we will touch the boundary between science and philosophy, between measurement and meaning. For to ask what the universe is to ask what it means to exist at all. The mind resists boundaries that are not physical. When we imagine an edge, we think of a cliff, a wall, a fence. But the universe, as far as science can tell, has no such barrier. Its limits are horizons of knowledge rather than surfaces of stone. To understand this is to realize that when we ask where the universe ends, we are often really asking where our understanding ends. The horizon is not a place we might someday travel to, but a veil that moves with us, marking the line between the known and the unknowable. The wonder of this fact is that we live inside a cosmic mystery. Every point in space has its own horizon. If we could teleport instantly to a galaxy billions of light years away, the universe we would see from there would be centered on that new position, with its own boundary of the observable. The universe is not a stage with a single spotlight. It is a vast play with countless centers of view. This symmetry, called the cosmological principle, tells us that our position is not special. The universe looks roughly the same from any vantage, stretching outward in all directions without sign of an edge. And yet the question lingers. If the universe is everything, then what would it mean to leave it? To leave implies crossing a border, stepping out from inside to outside. But outside the universe is not like the sea beyond the shore. It is not even like the void beyond the atmosphere. It is a concept without anchor. If all of existence is within the universe, then to leave existence is to enter non-existence. That is not a place, but an absence of place. The paradox leaves us uneasy, because our language is built for finite things. We can describe oceans and mountains, but not the end of being itself. There is a subtle beauty in this tension. The universe defines itself by including all, yet human curiosity insists on asking about what lies beyond the all. This insistence is not foolish. It is the drive that has carried us from myths of a solid dome to the mathematics of curved space-time. By pushing against the boundary of language, we discover new horizons of thought. Perhaps the very act of asking whether we can leave the universe is what allows us to expand our definition of it. In the end, definitions are tools, not prisons. To say the universe is all space and time is useful, but it need not be final. As theories of inflation, quantum mechanics, and multiverse ideas unfold, our sense of the universe may grow to include regions or realities beyond what we once thought possible. The word universe may stretch again, just as it did when humanity first realized the Earth was not the center of the cosmos. Our definitions evolve as our understanding does. For now, we stand beneath the stars and call the whole of it the universe. We know its observable span, its age, its composition, and yet we acknowledge that these are only glimpses. We define it as best we can with mathematics and metaphors, knowing the full truth may remain forever hidden. And still, the question remains open, shimmering at the edge of thought. If the universe is everything, then what could it mean to leave it? That question is the doorway to the next stage of our journey, where we must confront the idea of the universe's edge and whether such a thing exists at all. Not a wall, not a surface, but an edge that is not there, a limit born not of matter, but of perception. It is to that strange and subtle frontier that we now turn. When most people imagine the universe, the mind drifts toward pictures of a great sphere. There is a temptation to see it as a kind of bubble floating in emptiness, glowing faintly with galaxies along its shell. If this is the universe, then perhaps it has an edge, a final wall one could reach if only they traveled far enough. This intuition is ancient and understandable, but it is also misleading. The universe, as described by relativity and cosmology, does not behave like a sphere inside a greater void. Its edges, if they exist at all, are not the kind of edges we know in daily life. Consider again the balloon analogy, often used by physicists. Imagine ants crawling on the surface of a balloon. To the ants, the surface is their universe. If the balloon expands, every ant sees every other ant moving away, even though no ant is truly at the center. The surface has no edge, only curvature. If an ant were to walk forever, it would eventually circle back to its starting point. The balloon has a boundary in the sense that the surface is finite, yet it has no edge from the ant's perspective. The challenge is that our universe may behave in a similar way, only in 3 dimensions of space rather than 2. This idea of a finite but unbounded universe was made possible by Einstein's equations. They showed that space could curve back on itself, producing a cosmos with no physical wall, but also no infinity. The shape is hard to picture because we cannot truly visualize 4-dimensional geometry, yet the mathematics is consistent. A universe could be the 3-dimensional surface of a 4-dimensional sphere, looping back on itself so that travel in a straight line might eventually return you to where you began. But our universe might also be infinite, stretching outward without end, with galaxies filling it forever. In that case, there is no edge because there is no end. The question of finiteness remains unresolved. Current observations of the cosmic microwave background suggest that space is very close to flat, which implies either an infinite universe or one so large that its curvature is beyond detection. Either way, no edge has ever been found. It is important to note that in relativity, there is no outside. Space and time together form the arena of existence. To ask what lies beyond is to ask what lies outside existence itself. The balloon analogy can mislead if taken too literally, for a balloon does float in air, but the surface of the balloon does not need the air in order to be a surface. Likewise, our universe does not need an outside in order to exist. It is its own totality. Still, the human mind craves an ending. We walk to the shore and see the sea. We climb a mountain and see the sky. Always there is something beyond. The absence of a beyond unsettles us. It seems incomplete. We want to ask where the container sits, what it rests in, what holds it. This instinct is powerful, but in cosmology, it may be a trap. The universe may not rest in anything. It may simply be. The beauty of this realization is that it transforms the idea of an edge into something subtler. There may be boundaries in time rather than space. The Big Bang marks the beginning of the universe as we know it. The distant future may mark an end. But in space itself, there is no wall to crash against, no end of the road. The cosmos extends either without end or in a curve that returns upon itself. To seek an edge in the ordinary sense is to look for something that does not exist. And yet, even as relativity closes one door, other theories open another. The concept of cosmic inflation, a rapid expansion thought to have occurred in the earliest fraction of a second, suggests our visible universe is only a patch of a far larger reality. According to this picture, space may have ballooned in countless regions, each becoming its own bubble universe. In that case, our universe would indeed have a kind of edge, not a physical wall, but a boundary where our bubble ends and another begins. This moves us into the realm of the multiverse, where edges are not the absence of space, but the meeting of different spacetimes. But this is speculation, not established fact. Within the framework of relativity, as we currently test it, the universe has no physical edge. The phrase, "the edge that is not there," captures this paradox. We search for a border, but what we find is endless continuation, or curvature without end. The true limits are not in space, but in what we can know, what light can show us, and what our equations can describe. To imagine the universe without an edge is to stretch our thinking beyond the familiar. It is to accept that our intuition may not be the right guide. But it is also to embrace the wonder of a cosmos that does not need a container, that exists wholly in itself, and it sets the stage for deeper questions. If there is no edge in the ordinary sense, then what lies beyond the horizon of our vision? What realities may inflation or other theories reveal? These questions carry us into the next chapter, where we confront the cosmic horizon itself, the ultimate boundary of what we can see and perhaps ever know. The search for an edge to the universe reveals more about the limits of human imagination than it does about the cosmos itself. When explorers of old mapped the seas, they sometimes marked the boundaries of their knowledge with warnings of monsters or the words "here be dragons." Those maps had edges because their world was incomplete. Our cosmic map, by contrast, does not end in a wall of dragons, but in horizons of light. It is not the universe that ends, but our ability to see. The reason is simple, yet profound. Space is not static. It stretches and evolves. Galaxies are carried away from one another, not because they are flying through pre-existing emptiness, but because space itself is expanding. This expansion creates illusions of edges where none exist. From any given point, it looks as if everything is rushing away, faster the further you look. If one could stand on a distant galaxy, they would see the same pattern, with our home drifting into invisibility. Each observer is at the center of their own observable bubble, but none are at the center of the universe itself. This is why the question of an edge is so deceptive. It assumes there must be a vantage point from which the whole can be seen at once, as if the universe were a planet viewed from above, But relativity denies us that perspective. There is no outside balcony from which to look down on existence. There is only the inside view, woven into the fabric of space-time. The edge is an illusion born of trying to picture the infinite with finite intuition. Imagine standing on the surface of the Earth, believing it to be flat. Walk far enough, and surely you will reach an edge. Sailors once feared they might tumble over, but in truth, the Earth is curved, and one can walk endlessly without encountering a boundary. The surface is finite, but without an edge. Something similar may hold for the universe. If it is curved back on itself, one might travel forever without finding a border, eventually looping back to the start. But unlike the Earth, the universe curves in dimensions beyond direct visualization, so the analogy breaks down. Our words reach for shapes we cannot see. The alternative is that the universe is infinite. In that case, there is not even a loop, only endless expanse. The idea of infinity is both liberating and unsettling. If the universe is infinite, then every pattern of matter may repeat endlessly. Somewhere beyond any horizon, there could be another region indistinguishable from our own, with galaxies, planets, and perhaps even beings pondering the same questions. Infinity removes the edge by removing the ending. Science leans on observation to decide between these possibilities, but the evidence is subtle. Measurements of the cosmic microwave background show a universe that is remarkably flat on large scales, suggesting either infinity or a curvature so vast that we cannot detect it. No sign of an edge has appeared. No asymmetry hints at a wall. For now, the cosmos looks either infinite or unbounded, each equally mysterious. And yet, in the realm of theory, new pictures arise. Inflationary cosmology suggests our observable region is just one pocket of a greater inflating space. In this view, there may indeed be boundaries between regions, though not in the sense of cliffs or walls. They would be transitions between domains of space-time, separated by distances so immense they may as well be unreachable. The edge here is not a line to cross, but a change of reality itself. If such edges exist, they may carry with them different laws of physics, different constants, perhaps even entirely different kinds of matter. These speculations remind us that the edge of the universe is not a simple question of geometry. It is bound up with the deepest mysteries of physics. Does space extend forever? Does it curve into itself? Or is it part of a larger multiverse with domains divided by horizons we cannot cross? Each possibility challenges our intuition in a different way, and each reshapes what we mean by edge. To hold these questions in mind is to realize that the edge of the universe is less a line to be discovered and more a mirror held to our understanding. It shows us where our knowledge fades and our imagination begins. The cosmos itself may not need an edge, but the human mind seems unable to rest without asking for one. Perhaps it is our way of reaching beyond, of refusing to accept limits, of demanding that even the infinite must be framed. This restless impulse is not a weakness, but a strength. It has driven exploration across oceans and inquiry across centuries. It will drive us further still, as we turn from the idea of edges to the more subtle truth of horizons. For if there is no wall to the universe, there remains a boundary more real and more implacable. The cosmic horizon, the frontier set not by imagination, but by the very speed of light. The idea of an edge that is not there invites a deeper kind of humility. We are accustomed to thinking of travel as conquest, of distances as challenges to be overcome. A mountain may be climbed, an ocean may be crossed, and even the sky has yielded to wings and rockets. But the universe does not present itself in this way. It does not end in a line we might someday reach with faster ships or greater courage. Its boundaries are woven into the nature of space and time themselves. making them unreachable, not because of our weakness, but because of the structure of reality. In the early days of astronomy, the night sky seemed like a dome scattered with stars. It was natural to assume that beyond the dome lay something else, perhaps the realm of gods or pure darkness. When telescopes revealed more and more stars and later galaxies, the dome gave way to an expanding horizon. The question of what lies beyond simply receded. The further we looked, the more there was to see, and yet the promise of a final border never appeared. The dome had no wall, only endless depth. One might think that with enough time and technology we could solve this mystery, that the edge would finally be revealed. But the mathematics of relativity tells another story. Even if we had limitless energy and could accelerate forever, there are regions of space we could never reach. Galaxies far enough away are carried by expansion faster than light itself, not because they are moving through space, but because space is stretching between us and them. No rocket can outrun the growth of space-time. The edge is not a place we could approach more closely with faster engines. It is an absolute horizon, a limit not of technology, but of the cosmos itself. This changes the meaning of exploration. It tells us that discovery has an inherent boundary. We can map our observable patch, perhaps even colonize regions of our galaxy, but beyond a certain distance, the universe is forever closed to us. We live in a cosmic island, cut off from the greater sea. The edge we sought is revealed not as a wall in space, but as the limit of communication, the silence that lies beyond the reach of light. Yet there is a strange beauty in this. To live in such a universe is to live with mystery that can never be exhausted. No matter how much we learn, there will always be more beyond reach. The cosmos remains larger than any map, richer than any chart. This unending horizon is a gift as much as a barrier, for it ensures that wonder will never run dry. Still, the mind resists. It asks again, what if there is truly an outside? If space is curved, what does it curve into? If the universe is infinite, what contains the infinite? These are questions that push against the boundaries of physics into philosophy. Perhaps they cannot be answered within the language of science, which defines the universe precisely as all that exists. To ask what is beyond existence is to step into paradox. And yet even paradox has value, for it reveals the contours of our thought, showing us where the tools of reason end and the hunger for meaning begins. The edge that is not there, then, is both a scientific insight and a philosophical riddle. It reminds us that the universe may not conform to human expectation, that reality is under no obligation to fit our metaphors. But it also reminds us that our drive to imagine beyond the edge is part of what makes us human. We cannot help but ask what lies outside, even if outside has no meaning. And so, as we close this chapter, we recognize that the edge of the universe is not a place, but an idea. It is a shadow cast by the limits of perception and the reach of thought. The real frontier is not a wall, but a horizon, and it is to that horizon we must now turn. For in the next stage of our journey, we will meet the cosmic horizon itself, the true boundary of the knowable, and ask whether anything can ever lie beyond it. When we lift our eyes to the night sky, we are looking back in time. Light is not instant. It takes years to cross the abyss. The glow of the moon is more than 1 second old. The light of the nearest star is more than 4 years old, and the faint shimmer of the Andromeda galaxy left its stars more than 2 million years ago. To see distant light is to see history written across the heavens. This is the first hint of a profound truth. There is a limit to how far we can see, a final wall of time. That wall is called the cosmic horizon. The cosmic horizon is not a barrier in the ordinary sense. There is no surface floating in space, no curtain we could touch if we flew far enough. It is instead the distance beyond which light has not yet reached us. the universe is about 13.8 billion years old, so we might expect the furthest distance we could see to be 13.8 billion light-years. But the expansion of space has stretched that distance to about 46 billion light-years. Every direction we look, the farthest galaxies sit at that immense radius. Beyond them lies more universe, but no light from those regions has yet arrived. This observable sphere is our cosmic island. Inside it, we find galaxies numbering in the trillions, arranged in great clusters and filaments that weave across space like a cosmic web. Beyond it, we suspect, lies more of the same, continuing without end. But those outer realms are sealed away, hidden not by darkness, but by time itself. Even if we wait forever, much of that distant universe will remain hidden, because expansion carries it away faster than light can cross the gap. This creates two distinct horizons. The first is the particle horizon, the maximum distance light has traveled since the Big Bang. It defines what we can see today. The second is the event horizon, the limit of what we can ever see. Even in principle, galaxies beyond that horizon are lost to us permanently, their light forever unable to catch up. In effect, parts of the universe are slipping from view, receding not just from our eyes but from our future. The cosmic horizon reshapes how we think about exploration. On Earth, horizons are temporary. Sail far enough and the line of the sea opens to reveal more. Climb high enough and the distant landscape comes into view. But the cosmic horizon is different. It is not an illusion of perspective. It is a boundary set by the laws of space-time. No telescope will ever peer beyond it. No starship will ever cross it. The horizon is absolute. And yet it is not empty of meaning. Within this horizon lies all of human history, every galaxy we can ever touch, every star we can ever study. It defines our cosmic neighborhood. When astronomers map the sky, they are not charting the whole universe, but only this visible portion. To call it a horizon is to admit that we are not seeing the whole picture, that there is more beyond, but hidden forever from view. This raises a profound question. If most of the universe is beyond our horizon, can we ever claim to know what the universe truly is? We infer its shape and fate from the part we can see, but we must always remember that this is only a fraction. We are like sailors charting the coast of a continent while knowing nothing of the inland. Our models may be correct, but they may also be partial. The unseen regions may hold surprises, and yet the horizon does not leave us powerless. By studying the oldest light, the cosmic microwave background, we glimpse conditions close to the beginning. By observing the clustering of galaxies, we infer the presence of dark matter and dark energy. Even within our horizon, the clues are rich. The universe whispers its secrets if we listen carefully enough. The cosmic horizon is therefore both a limit and a gift. It humbles us by reminding us of what we cannot reach, but it also guides us by showing what is possible to know. Within this vast sphere lies more wonder than we could ever exhaust. The galaxies visible to us today will keep astronomers busy for as long as humanity survives. And the very existence of the horizon sparks the imagination, urging us to ask whether there might be ways, however speculative, to slip past it. For the horizon is not only a physical boundary, it is also a challenge to the imagination. If nothing can cross it in the ordinary sense, could there be extraordinary ways around it? Could wormholes, shortcuts through space-time, or other exotic phenomena offer a path to the unseen? The horizon may be unbreakable, but that has never stopped human curiosity from dreaming of ways to reach beyond. And so, as we close this first part, we arrive at the threshold of speculation. The cosmic horizon defines what is possible today, but to ask whether we can leave the observable universe is to ask whether physics holds hidden doors. The next step in our journey will be to peer into those possibilities, where theory meets imagination, and the dream of surpassing horizons takes shape. The cosmic horizon is more than a scientific detail. It is a mirror that shows us the limits of existence as we can experience it. To live in this universe is to live inside a sphere of visibility, bounded not by walls, but by time. We are accustomed to thinking of boundaries as obstacles to be overcome, but this is a boundary that will never yield. Even with perfect technology, even with infinite patience, the horizon will remain. It is not a line we can chase, but a fact of cosmic geometry. This fact is made stranger by the expansion of the universe. When light leaves a distant galaxy, it begins a long journey across space-time. But as it travels, the fabric of space stretches. The wave crests are pulled apart, their wavelength growing longer, turning visible light into infrared and eventually into radio waves. This redshift is the signature of cosmic expansion. It means that by the time the light reaches us, billions of years later, it has been weakened and stretched by the growth of the universe itself. The most ancient light, the glow of the cosmic microwave background, has been stretched by a factor of more than 1,000 since it was first emitted. This stretching has another consequence. Galaxies that are far enough away are receding faster than light. They are not breaking any rules because nothing is moving through space faster than light. Rather, it is space itself that is expanding, carrying the galaxies with it. From our perspective, their distance increases faster than light can cross it. The result is that their signals can never reach us. They lie beyond the event horizon, cut off forever. This leads to a startling thought. As time passes, more and more galaxies slip beyond the horizon. The observable universe today is filled with trillions of galaxies, but in the deep future, only a handful will remain visible, bound to our local group by gravity. Far away, the rest will fade into unreachable silence. The cosmos will appear emptier, though in truth it will be as full as ever, just hidden beyond the shrinking horizon of what can be seen. It is strange to think that the universe we experience is shrinking, even as it expands. The totality of existence may grow ever larger, but our accessible patch becomes smaller with time. To our distant descendants, if any survive, the sky will be dark and lonely. They may not even know that other galaxies ever existed. Their horizon will have erased the evidence. The cosmic truth that we know today is a gift of timing. We live at a moment when the universe is vast but still visible, when the past is still written in light. For philosophers and scientists alike, this horizon has a deeper implication. It means that knowledge itself has boundaries. We often think of science as limitless, as an ever-expanding conquest of the unknown. But the horizon teaches us that some mysteries are absolute. We will never map the full universe. We will never send a probe to galaxies beyond the event horizon. We can imagine them, we can model them, but we can never touch them. They are beyond the reach not just of human effort, but of possibility itself. And yet, this does not diminish the wonder of what lies inside. Within our cosmic bubble, every atom of our bodies was forged in the hearts of stars. Every photon of sunlight is a message from a nuclear furnace 93 million miles away. Every galaxy is a cathedral of gravity and light. The horizon limits us, but it also frames our stage, reminding us that our portion of the cosmos is already a miracle beyond measure. Still, the imagination resists limits. It insists on asking whether there is some way around them. Could there be hidden pathways through space-time, shortcuts that leap past the rules of light speed? Could the mathematics of general relativity, which already allows for strange solutions like wormholes, hold a secret that would let us pierce the horizon? Such ideas remain speculation, but they reveal something important. The horizon is not just a wall. It is an invitation to dream. Thus, the cosmic horizon, though absolute, is not the end of curiosity. It marks the place where science meets imagination, where the known meets the hoped for. We may never pass it in reality, but by considering what it means, we step into a larger realm of thought. And it is there, in that realm, that humanity has always found its next great journey. The horizon is the most honest teacher the universe has given us. It shows us not only the grandeur of the cosmos, but also the boundaries of our reach. To grasp this lesson is to accept that there are questions which cannot be answered through observation alone. Beyond the horizon may lie regions of space just like ours, or regions profoundly different, but we cannot know. They exist outside the chain of cause and effect that connects us to reality. Light is the carrier of information, and where light cannot go, knowledge cannot follow. And yet the very existence of the horizon pushes us toward deeper ideas. The thought that most of the universe is forever hidden forces us to reconsider what we mean by universe itself. Do we define it as the part we can see, a sphere 46 billion light years in radius? Do we define it as the totality that lies beyond, whether infinite or curved back on itself? Or do we broaden the definition further still, to include possibilities of other domains, other bubbles, other spacetimes that inflationary theory suggests may exist? The horizon presses us to clarify our language, because each definition leads to different consequences when we ask whether we might ever leave. There is also the mystery of time. The horizon is not only a boundary in space, but in history. When we look across the universe, we are looking backward. The galaxies at the edge of sight are not seen as they are today, but as they were billions of years ago. The horizon is therefore not only a wall of distance, but a wall of memory. We see the past, but never the present, and never the future. The horizon is where history itself becomes invisible. This makes the universe a kind of cosmic stage play in which we are both audience and actors. We sit in the present, watching the light from ancient scenes unfold across the sky. The drama continues in real time, but much of it is beyond our view. The play is larger than the theatre we can see. The horizon is the curtain that hides the rest of the performance, reminding us that we do not see the whole story, only a portion chosen by the limits of light. Still, the knowledge we have is extraordinary. By studying the light within our horizon, we have learned that the universe is expanding, that galaxies cluster in great filaments, that dark matter outweighs visible matter 5 to 1, and that dark energy drives the acceleration of expansion. We have mapped the history of stars and traced the chemistry of life back to nuclear furnaces in stellar hearts. All of this from within a single cosmic bubble. If this much can be known without ever crossing the horizon, then perhaps the limits are less a cage than a challenge. But always the imagination returns to the same longing. Could there be a way around the horizon? Could there be structures in space-time, wormholes or tunnels that connect distant regions without crossing the intervening space? Could physics allow us to step outside the rules that hold the horizon in place? These are not answers we have, but they are questions that will not go away. The horizon may be fixed, but human curiosity is not. The cosmic horizon, then, is not simply a limit. It is a teacher of humility, a source of wonder, and a spark for speculation. It reminds us that the universe is larger than we will ever see, that knowledge has boundaries, and that imagination is the tool by which we reach beyond them. To understand the horizon is to stand at the edge of the known world and gaze into the unknown, knowing we will never cross it, but also knowing that the act of looking changes us. And so, as we bring this chapter to a close, we find ourselves at a turning point. We know what the horizon is and why it cannot be crossed. But we also know that the laws of physics sometimes allow strange possibilities. General relativity admits solutions that look like tunnels through space-time. Quantum theory hints at fluctuations and connections that defy ordinary intuition. If we cannot cross the horizon in the usual way, perhaps we can imagine extraordinary ways. It is to those possibilities that we now turn as we step into the realm of wormholes and hyperspace dreams. The cosmic horizon tells us there are regions of the universe forever beyond our reach. Yet human curiosity does not rest. If space will not allow us to cross, perhaps space itself can be persuaded to bend. This is where the imagination seizes on the strange corridors predicted by general relativity, paths known as wormholes. They are not inventions of fantasy, though they have become a staple of science fiction. They emerge naturally from the mathematics of Einstein's equations, as possible solutions in the geometry of space-time. A wormhole, in simplest terms, is a tunnel through space-time. Instead of traveling the long distance between 2 points, one might pass through a shortcut, emerging in another place instantly, or nearly so. To visualize this, physicists sometimes use the image of a sheet of paper. Draw 2 dots on opposite sides of the sheet. To connect them, one could draw a line across the surface, a long route. But if the sheet is folded so the dots touch, the distance is reduced to almost nothing. A wormhole is like that fold, though in space-time rather than paper. The earliest version of this idea was the Einstein-Rosen bridge, described in 1935 by Albert Einstein and Nathan Rosen. They found that relativity allows 2 black holes to be connected, forming a bridge. At first, this seemed to offer a way to pass from one region of space to another. But further analysis revealed a problem. The bridge collapses too quickly for anything to cross. The tunnel pinches shut before matter or light can traverse it. In other words, the simplest wormholes are unstable, like doors that slam shut the moment they open. Still, the idea was too compelling to abandon. In the 1980s, Kip Thorne and other physicists explored whether wormholes could be made traversable. Their studies showed that, in theory, a wormhole might be held open by a form of exotic matter. This exotic matter would have negative energy density, something not found in ordinary experience, but not forbidden by quantum theory. If such material could exist, it might counteract the natural collapse of the tunnel, allowing a stable passage. The requirements, however, are staggering. The amount of exotic matter needed would be immense. The engineering challenge would be beyond anything imaginable today, and we do not even know whether negative energy in the required form can exist in macroscopic amounts. Wormholes remain speculative, not because the mathematics forbids them, but because the physics of matter and energy may not cooperate. Yet the mere possibility is tantalizing. If wormholes could exist, they would not only allow shortcuts across space, but potentially across time as well. Depending on how the ends of a wormhole move, one side could experience time differently than the other. This raises the paradoxes of time travel, questions of causality, and challenges to our understanding of reality itself. Most physicists suspect that nature forbids such paradoxes, perhaps through mechanisms we do not yet understand. But the door, mathematically at least, remains ajar. For the imagination, wormholes are irresistible. They offer an escape from the tyranny of the horizon. Where ordinary space says no, a wormhole whispers maybe. Science fiction has long embraced this image, from starships leaping through hyperspace to explorers stepping into shimmering portals. These visions exaggerate and simplify the mathematics, but they capture the essence of the idea that space-time may hold hidden doors. The search for such doors is not confined to fiction. Physicists continue to study whether quantum effects might allow wormholes to exist in stable forms. Some propose that tiny wormholes could appear at the quantum scale, flickering in and out of existence in the foam of space-time. Others wonder whether black holes themselves might be connected in ways we cannot yet observe. While evidence remains absent, the pursuit is serious. For to discover a wormhole would be to discover a new dimension of travel, a a new way to think about existence itself. Even if traversable wormholes remain impossible, they serve another purpose. They remind us that the laws of physics are stranger than our intuition allows. Relativity does not describe space as flat and simple. It describes it as a fabric that can bend, twist, and even connect distant points. Wormholes are the most dramatic expression of that flexibility, showing that space is not merely an arena, but a dynamic participant in reality. And so, as we begin this chapter, we step from the realm of horizons into the realm of dreams. The horizon is a hard boundary, but wormholes suggest the possibility of slipping past. They may not exist, or they may be forever out of reach, but the very thought of them changes how we see the universe. They tell us that the cosmos may hold possibilities beyond straight lines, that shortcuts may lurk in the geometry of being. Whether real or imagined, wormholes represent the human refusal to accept limits, the drive to ask what if, and the courage to follow that question into the unknown. The thought of wormholes invites us to rethink the very nature of distance. We grow up with the intuition that space is a backdrop, a vast emptiness dotted with stars, and that to travel means to cross that emptiness step by step. Relativity shatters this picture. Space is not a passive stage, but a fabric that bends and flows. If it can bend, why not fold? If it can fold, why not connect distant regions like two points pressed together? A wormhole is not magic, but geometry, a reminder that distance is not as absolute as it appears. To consider wormholes seriously is to confront both possibility and impossibility at once. On one hand, the mathematics of general relativity allows such tunnels. On the other, the physics of matter may prevent them from being usable. Exotic matter with negative energy density is not a substance we can scoop into a container. It exists only in narrow contexts, like the Casimir effect, where quantum fields between plates create tiny amounts of negative energy. But these effects are vanishingly small, nowhere near enough to stabilize a cosmic passage. The gulf between what equations permit and what nature provides may be unbridgeable. Even if exotic matter were found in abundance, constructing a wormhole would be an engineering challenge on a scale beyond comprehension. The tunnel would need to be stabilized against collapse, shielded from radiation, and anchored in space-time in such a way that travelers could pass without being torn apart. The slightest imbalance could cause it to snap shut, destroying whatever was inside. Unlike rockets or telescopes, which build on existing principles, wormholes would require entirely new physics to control. And yet the concept continues to attract serious attention because of the questions it raises. Could wormholes exist naturally, formed in the early universe when quantum fluctuations were immense? If so, might some have survived to the present? Could black holes be entrances to hidden passages, their singularities connecting to other regions? These ideas remain speculative, but they push researchers to probe deeper into the union of relativity and quantum mechanics, where the ultimate structure of space-time is decided. Another reason wormholes fascinate is their connection to time. If one mouth of a wormhole is accelerated or placed near a massive gravitational field, time passes differently at each end. A traveler stepping through might emerge not only far away in space, but also displaced in time. The paradoxes of such travel are legendary. Could one meet their younger self or send messages into the past? Most physicists believe the universe protects itself against contradictions, perhaps through mechanisms like Hawking's chronology protection conjecture. But wormholes test these limits, showing where our theories may break. It is easy to dismiss these speculations as science fiction, but science fiction itself has always been a partner in exploration. By imagining what wormholes might allow, storytellers keep alive the questions that theory alone cannot answer. They explore what it would mean to walk through a doorway into another star system, to escape horizons, to slip past the barriers of space. These narratives exaggerate, but they also inspire, ensuring that the question of wormholes is never forgotten. There is also a philosophical allure. If wormholes exist, then distance itself becomes negotiable. The universe ceases to be a prison of vastness. Travel between galaxies, otherwise impossible, becomes a step across a threshold. It would be the greatest expansion of human possibility since fire or flight. Even if forever out of reach, the vision reshapes our sense of what the cosmos could be. Thus, wormholes, though uncertain, serve as a reminder that the laws of physics are not yet complete. Relativity alone tells one story, quantum mechanics another, and the marriage of the two may hold surprises. In the gaps between our theories, the possibility of shortcuts still lingers. Whether nature allows them or not, the dream of wormholes is a beacon, drawing us toward deeper questions about the fabric of reality. In contemplating wormholes, we see how thin the line is between science and speculation. The equations do not forbid them, but nature may. The mathematics sketches their outlines, but the physics leaves them empty. Still, they remain part of the conversation because they embody the human refusal to accept boundaries. Horizons may limit us, but our imagination refuses to be contained. And so, when we picture a wormhole shimmering in the void, we are not only picturing a possible feature of space-time. We are picturing our own hunger for escape, our own desire to reach beyond the limits imposed by light and distance. Wormholes are as much a reflection of ourselves as they are a product of relativity. They remind us that to ask what lies beyond is to be human, and that even when answers remain out of reach, the questions themselves carry us forward. The dream of wormholes does not rest only in mathematics. It has become a cultural symbol, a way for humanity to picture its longing to escape boundaries. When we imagine stepping into a tunnel that delivers us to another galaxy, we are imagining freedom from the greatest prison of all, the prison of distance. It is this symbolism that gives wormholes such enduring power in human thought. They are not only hypothetical structures of space-time, but also metaphors for transcendence. Still, the scientific questions remain sharp. Could the universe contain wormholes hidden from view? If so, how would we find them? They might reveal themselves through subtle gravitational effects, distortions of light from background stars, or signatures in the motion of matter near black holes. Physicists have searched for such evidence, but none has appeared. The universe offers us many wonders, but so far no doorway has opened. For now, wormholes remain theoretical, a possibility rather than a discovery. The absence of evidence does not end the story. Instead, it shifts the focus toward deeper theories of space-time. Quantum gravity, the elusive framework that unites relativity and quantum mechanics, may decide the fate of wormholes. Some approaches suggest that tiny wormholes may constantly appear and vanish in the seething foam of quantum space-time. If true, this would mean wormholes are real but microscopic, flickering at scales far smaller than atoms. They would be useless for travel, yet their existence would confirm that space-time is stranger than we can see. Other theories hint at a connection between wormholes and entanglement, the ghostly link between particles that share quantum states across distance. This idea, often summarized by the phrase ER equals EPR, proposes that wormholes and entanglement may be two faces of the same phenomenon. If correct, it would mean that the threads of quantum reality are woven with hidden connections, and that the geometry of space-time itself emerges from such links. In this vision, wormholes are not merely tunnels through space, but the scaffolding of existence. Whether or not these ideas are proven, they reveal the depth of the question. Wormholes are not only about travel, they are about the nature of reality. They ask whether space is truly continuous, where the distance is absolute, and whether the universe holds hidden dimensions of connection. In exploring them, we are not only seeking escape routes from horizons, we are seeking to understand the foundations of being. For the ordinary traveler, these questions may seem distant. Rockets and telescopes are real, wormholes are not. But science has always advanced by first entertaining possibilities that seemed impossible. Flight was once a dream, electricity a curiosity, quantum theory a puzzle without application. To think about wormholes seriously is not to expect them tomorrow, but to honor the imagination as a tool of discovery. Even when nature denies us, the act of asking sharpens our vision. Thus, wormholes remain both fantasy and frontier. They are symbols of escape, products of mathematics, and puzzles for physics. They may never be built, and they may never be found. But by contemplating them, we learn something essential about the human spirit. We learn that we are creatures who push against boundaries, who imagine beyond horizons, who look at the edge of the possible and ask what if. Wormholes remind us that curiosity itself is a kind of passage, a bridge that carries us from the known to the unknown. And so, we end this chapter where speculation becomes philosophy. The horizon set by light is absolute, but the mind refuses to stop at absolutes. Wormholes may never be more than equations on paper, yet they reveal a truth about us. To be human is to dream of doors where none exist, to imagine exits from prisons even when the walls are woven from space-time itself. This dream prepares us for the next step, for beyond wormholes lies an even larger speculation. The possibility that our universe is only one among many. To imagine a multiverse is to expand the idea of the cosmos itself, and to ask whether leaving the universe might mean leaving for another one altogether. The idea of wormholes tempts us with shortcuts through space-time. But what if the ultimate escape lies not in crossing this universe, but in discovering that there are others? For centuries, the word universe has meant the totality of existence. By definition, there could be nothing outside it. Yet modern physics has found itself whispering of something larger, a greater stage upon which our universe may be only one actor among many. This is the multiverse, a concept both daring and divisive. To speak of it is to stretch the meaning of reality itself. One of the strongest hints comes from the theory of cosmic inflation. In the earliest fraction of a second after the Big Bang, the universe is believed to have expanded at an inconceivable rate, doubling in size again and again in less than the blink of an eye. Inflation explains why the cosmos appears so uniform on large scales, and why space is so nearly flat. But inflation, once begun, may not stop everywhere at once. Some regions may finish inflating and form bubble universes like our own, while others continue to expand. The result is eternal inflation, a process that spawns countless universes, each with its own properties. If this picture is correct, then our universe is just one bubble in an endless froth. The others may be forever unreachable, separated from us by inflating space that grows faster than light. Yet they are real in the sense that they emerge from the same physics that gave rise to us. Some bubbles might resemble ours, with galaxies, stars, and perhaps life. Others might be strange beyond recognition, governed by different constants of nature, different patterns of symmetry, even different numbers of dimensions. The multiverse of inflation is a landscape where every possibility may find a home. Another route to the multiverse comes from quantum mechanics. The equations of quantum theory describe particles not as fixed entities, but as clouds of probabilities. When a measurement is made, the cloud appears to collapse into one outcome. But one interpretation, known as the many worlds interpretation, suggests that the cloud never collapses. Instead, all possible outcomes occur, each in its own branch of reality. Every quantum event spawns a splitting of worlds. In this picture, There is not one universe, but a branching tree of universes, endlessly proliferating, each containing versions of ourselves who lived out different choices. The scale of this idea is staggering. Every roll of the dice, every firing of a neuron, every quantum fluctuation could be birthing a new universe. The multiverse here is not a scattering of bubbles in space, but a branching of realities in the fabric of possibility. We do not move between them, but they exist alongside us, silent and invisible. To leave our universe in this sense would not be a matter of travel, but of finding a way to step between branches, a feat for which no known mechanism exists. A third possibility arises from string theory, the ambitious framework that seeks to unify all the forces of nature. String theory allows for a vast number of possible solutions, each corresponding to a different way the extra dimensions can be curled and compactified. The number of possibilities has been estimated as 10 to the power of 500, a landscape of universes so vast that our own seems like a single grain of sand on an endless shore. If string theory is true, then the question is not whether other universes exist, but why we find ourselves in this particular one. These different visions of the multiverse are not identical, but they share a common theme. They suggest that our universe is not unique. It is part of a larger reality, a mosaic of possibilities. To contemplate this is to expand the meaning of the word cosmos. The universe becomes not the totality of existence, but one island in an archipelago without end. Skeptics point out, rightly, that the multiverse is difficult to test. By definition, other universes are beyond our horizon. We cannot see them or interact with them directly. Science demands evidence, and without evidence, these ideas risk drifting into philosophy. Yet defenders argue that if the theories that predict them are supported by observation, then their consequences must be taken seriously. If inflation explains the uniformity of the cosmos, and inflation predicts other universes, then those universes are part of the theory's truth. The debate continues, but the allure is undeniable. The multiverse promises answers to deep questions. Why do the constants of nature have the values they do? Why is the universe so finely tuned for life? In a multiverse, the answer may be simple. We live in one of the rare universes where conditions allow us to exist, because only in such a universe could we ask the question. It is an anthropic explanation, unsatisfying to some, but perhaps inevitable. Thus, the multiverse stands at the boundary of science and speculation. It may never be observed, yet it may be real. It may remain forever theoretical, yet it may be the larger truth. And in contemplating it, we find ourselves once again asking the same question. If other universes exist, can we ever reach them? Could we ever leave not just our galaxy or our horizon, but our entire universe itself? That question carries us from physics into imagination, from the known into the possible, and from the word universe to the mystery that lies beyond it. The idea that our universe could be one of many is both unsettling and liberating. It unsettles us because it removes the sense of uniqueness. For centuries, we believed the Earth was the center of creation. Then we learned it was one planet circling one star among billions in the galaxy. Later, we learned our galaxy was just one among trillions in the observable universe. Each step diminished our special place, yet each step also expanded our vision. The multiverse continues this progression, suggesting that even our universe is not the whole story. What once seemed like everything may itself be only one chapter in an infinite library. At the same time, the idea liberates us. If there are countless universes, then the limits of possibility are broken open. Somewhere, the laws of physics may be slightly different, producing stars that live longer or shorter lives, elements that combine in other patterns, or landscapes where life is unimaginable. Somewhere, gravity may be weaker, time may flow differently, or space may have more than 3 dimensions. Every variation permitted by mathematics may exist somewhere in the multiverse. Our universe is then not the inevitable product of one set of rules, but one realization among many. This vision can seem overwhelming, but it has a certain logic. Physics has long sought a final theory, a unique set of laws from which everything follows. But string theory and inflation suggest a different picture. Instead of one inevitable universe, the equations allow for a vast range of possibilities. The multiverse is not a flaw in the theory, but a consequence of its richness. Nature, it seems, may not be singular, but plural. The question then becomes how to relate to this plurality. If the multiverse exists, but remains forever beyond observation, does it belong to science? Some argue that it does, because science is not limited to what can be directly seen. Atoms were once invisible, yet their effects were measurable. The multiverse, though not observable, might explain the fine-tuning of our universe, giving it indirect support. Others argue that without testability, it risks slipping into metaphysics, a realm where belief and speculation replace evidence. This tension is not easily resolved. It touches the philosophy of science itself. How do we define reality? Is it only what can be observed, or is it also what must exist for our theories to make sense? In struggling with these questions, we are reminded that the border between physics and philosophy is not a wall, but a horizon, shifting as knowledge expands. Meanwhile, the multiverse continues to inspire thought experiments. If bubble universes from eternal inflation collide, they might leave scars in the cosmic microwave background. Astronomers have searched for such imprints, circular patterns in the ancient light, but none have yet been confirmed. If the many worlds interpretation is true, then every quantum decision spawns another universe. In this case, universes are born every moment, yet by construction, they are unreachable. If string theory's landscape is real, then universes fill an immense possibility space, perhaps connected in ways we do not yet understand. Each scenario is different, but all share the same underlying theme. Our universe may not be all there is. To imagine the multiverse is to shift from thinking of reality as a single canvas to thinking of it as a gallery of canvases, each painted differently. We see only one, but the gallery may be endless. This change of perspective is profound. It means that leaving the universe may not mean leaving existence altogether, but stepping from one canvas to another. It changes the very meaning of the question, could we ever leave? And yet, the difficulties remain. Even if other universes exist, they may be forever sealed from us, unreachable not only in practice, but in principle. The inflationary bubbles are separated by expanding space that grows faster than light. The quantum branches are parallel, yet non-communicating. The string theory landscape is vast but disconnected. The dream of reaching another universe may be no more achievable than reaching the edge of our own. Still, the idea lingers because it touches something deep. To imagine other universes is to imagine that reality itself is larger than our comprehension. It is to accept that the word all may not mean what we thought it meant. It is to stand once again at the horizon of thought, facing outward into a greater unknown. And so, the multiverse invites us to ask not only what is, but what could be. It invites us to imagine not only this universe, but the possibility of others. Whether or not we can ever prove it, the concept expands our imagination. It prepares us for the next question. If other universes exist, what barriers lie between us and them, and could those barriers ever be crossed? The multiverse is at once a scientific proposal and a philosophical mirror. It asks us to confront the possibility that our universe is not singular, but one among an uncountable many. This changes the way we think about identity and meaning. If there are endless versions of reality, then what does it mean to be here, in this one? Are we a chance fluctuation, one lucky outcome in a vast lottery of possibilities? Or is our existence inevitable, written into the fabric of the multiverse itself? Some physicists embrace the anthropic principle as an answer. In a multiverse of many different universes, only a few will have the right conditions for stars, planets, and life. It is no surprise that we find ourselves in one of those few, because only here could observers exist to ask the question. This reasoning is unsatisfying to some, for it replaces explanation with selection. It tells us why we are here, but not why the universe is this way. Yet perhaps that is the only answer nature allows. Others look for deeper patterns. Perhaps the multiverse has structure, a hierarchy of possibilities shaped by deeper laws. Perhaps the constants of physics vary only within certain ranges. Or perhaps universes are born from one another, linked in chains of creation. These ideas remain speculative, but they show the human refusal to accept randomness as the final word. Even in a multiverse, we seek meaning, order, and law. The greatest challenge of the multiverse is that it may lie forever beyond testability. We cannot see beyond our cosmic horizon, and we cannot step into another bubble of inflation. The many worlds of quantum mechanics are, by design, non-communicating. String theory's landscape may be real, but inaccessible. Critics argue that this makes the multiverse unscientific, a concept too far removed from observation. Yet supporters counter that theories must be judged by their internal consistency and explanatory power. If inflation, quantum mechanics, and string theory all point toward a multiverse, then the idea cannot be dismissed simply because it lies beyond our reach. This tension highlights a deeper truth. Science is not a fixed set of rules, but a living process. It grows by stretching the boundaries of what can be observed, always reaching for the unseen. At times, it must follow the mathematics into realms that may not yield direct evidence, trusting that coherence and prediction will eventually bring clarity. The multiverse may be one of those cases, a horizon of thought that beckons us even if we never cross it. For the imagination, the multiverse is a fertile field. It offers endless stories, endless variations of reality. It suggests that every possibility may be real somewhere, that every choice may be played out, that every dream may find a home. To contemplate it is to feel both small and infinite, one being in one universe among countless others. It humbles us and exalts us at once, showing us that reality is larger than our wildest vision. And yet the practical question remains: if other universes exist, can we ever reach them? Could there be a doorway, a bridge, a connection through which travel is possible? Or are we forever sealed within our bubble, our branch, our patch of the cosmic landscape? The answer is unknown. For now, the barriers between universes appear absolute. They are separated by expanding space, by quantum silence, by differences so deep that crossing may not even be meaningful. Still, the idea of other universes forces us to think beyond the boundaries of our own. It reminds us that our definitions are provisional, that the word universe may not capture all that exists. It pushes us to imagine a greater totality, a reality of realities, and in doing so, it prepares us for the next step in our journey. For if other universes exist, we must ask what barriers keep us apart, and whether those barriers are walls of impossibility or simply horizons yet to be understood. If the multiverse is real, then our universe is not alone. It is one bubble in an endless sea of bubbles, one branch of a limitless tree, one note in a cosmic symphony. Yet the very idea of other universes raises a difficult question. What separates them from us? If they exist, why can we not see them, touch them, or reach them? The answer lies in the barriers that divide one universe from another, barriers that are not fences of stone but differences in the very fabric of reality. In the model of eternal inflation, universes form like bubbles in a boiling pot. Each bubble inflates into its own cosmos, with its own laws of physics. The space between bubbles expands faster than light, pushing them apart, sealing them from one another. The barrier here is not a surface we could cut through, but an inflating gulf that grows forever wider. If two bubbles collide, they might leave scars, vast imprints in the structure of space-time. But such collisions would be rare and violent, more like cosmic catastrophes than passages. For the most part, each bubble is forever isolated, a self-contained reality. In the many worlds interpretation of quantum mechanics, the barriers are even stranger. Here, universes do not float in space, but branch from one another in the realm of possibility. Every quantum decision splits reality into multiple versions. The barriers between these versions are absolute, for by construction, the branches do not interact. They are like parallel books being written simultaneously, with no shared pages. To cross from one to another would mean defying the mathematics itself. It is not a journey through space, but a break in logic, an impossible step across definitions. In the landscape of string theory, the barriers may be differences in dimensions themselves. Each universe is defined by the way extra dimensions are curled and compactified. To move from one to another would mean unfolding and refolding the fabric of space at its most fundamental level. The laws of physics might change in the process, rewriting the rules of matter, energy, and time. The barrier here is the very structure of reality, as though each universe is written in a different language and translation is forbidden. These barriers make the idea of leaving our universe more than a technological challenge. They make it a conceptual challenge. A spaceship can cross distance, but what could cross a gulf of inflating space? A traveler can pass through a door, but what could pass from one branch of possibility into another? These are not distances to be measured in kilometers, but differences in being itself. They are not walls to be broken, but definitions to be rewritten. And yet, physics allows for moments when barriers might be thin. If bubble universes collide, the imprint might be seen in the cosmic microwave background, faint circles or distortions that hint at contact. If quantum mechanics has deeper layers, there may be ways in which branches influence each other subtly, though no evidence has yet been found. If string theory's landscape is connected by higher dimensional paths, there may be mathematical ways to imagine transitions, though they may remain forever abstract. These are glimpses, not promises, and for now the barriers appear absolute. To confront these barriers is to confront the possibility that our universe is a prison not only of space, but of principle. It is to imagine that even if countless universes exist, we may never touch them. They are not waiting just beyond the horizon, but sealed behind walls of physics itself. To leave our universe may therefore be impossible, not because we lack the courage or the tools, but because the very idea is incoherent. And yet, the human mind resists. We imagine doorways because we cannot help it. We picture what it would mean to break through, even if the walls are unbreakable. This resistance is not foolish. It is the same drive that carried us from caves to continents, from continents to planets, from planets to stars. The barriers between universes may be absolute, but the act of imagining beyond them shapes our understanding of what is. Thus, the barriers are not only physical, they are philosophical. They remind us that words like universe, multiverse, and reality are not fixed, but stretch as our knowledge grows. They remind us that every horizon invites a beyond, even if that beyond is unreachable, and they prepare us for the next step in our journey. For if barriers forbid us from leaving, then perhaps the real question is not how to escape, but how to imagine escape. That is where science fiction begins, and where our reflections must follow. The thought of barriers between universes forces us to reconsider what we mean by travel. In ordinary life, travel means moving from one place to another, crossing a measurable distance. Even journeys to the moon or to distant planets are still journeys across space. But if the multiverse is real, then the barriers between universes are not distances at all. They are separations in the structure of reality itself. To imagine crossing them is to imagine something beyond movement, something closer to transformation. Consider again the inflationary bubbles. Each is wrapped in a boundary where the energy of inflation gives way to the physics of that universe. This boundary is not a membrane one could pierce with a spacecraft. It is a zone of changing laws, where the very constants that define matter and energy shift. To pass through such a boundary, if it were possible at all, would mean leaving behind the chemistry that makes atoms stable, the forces that shape stars, the fabric that allows life. On the other side might be a universe where gravity is stronger, where atoms cannot form, where light behaves differently. In this sense, the barrier is not only physical, but existential. Crossing it would not mean traveling into a new land, but into a reality where our kind of existence could not survive. In the quantum many-worlds picture, the barrier is even more absolute. Universes are not separated by distance or energy, but by the branching of possibilities. They are non-interacting by design, mathematical consequences of the wave function, rather than regions of space. To imagine crossing from one branch to another is to imagine altering the logic of quantum mechanics itself. It would be like stepping from one number line into another, changing not position, but the rules of arithmetic. Such a step may simply be incoherent, forbidden not by lack of technology, but by the structure of logic itself. And in the landscape of string theory, the barriers are differences in geometry at scales smaller than atoms. Each universe is defined by the way hidden dimensions fold in on themselves. These folds determine the particles and forces that exist. To move from one configuration to another would mean unfolding space-time and refolding it into a new shape. The energies required would be beyond imagination, far greater than anything the universe has displayed since its first moments. Here the barrier is the architecture of being, the blueprint of reality itself. Faced with such barriers, one might conclude that the dream of leaving the universe is impossible. And yet, the idea continues to inspire because barriers are not only obstacles, they are also invitations. They mark the places where curiosity presses hardest, where imagination refuses to yield. The barriers between universes tell us that our definitions are provisional, that reality may be larger than what we can reach. They challenge us to rethink what travel, existence, and escape truly mean. There is also the possibility that collisions or connections between universes have already occurred. If our bubble once brushed against another, the impact might have rippled through the cosmic microwave background, leaving faint scars. Some astronomers have searched for such patterns, though none are confirmed. If quantum branches influence one another subtly, there might be traces in entanglement or decoherence. If the string landscape has higher dimensional pathways, they might leave mathematical fingerprints in the laws we observe. Evidence is scarce, but the search itself sharpens our tools, teaching us how to distinguish what is ours from what might be beyond. The barriers remind us of another truth, that impossibility in physics is often provisional. Once, heavier than air flight seemed impossible. Once, the atom was thought indivisible. Once, the universe was believed eternal and unchanging. Each barrier fell when deeper understanding arrived. This does not mean all barriers will fall. Some may be absolute. But we cannot know which without pressing against them. To declare a barrier final is to stop looking, and science has never thrived on stopping. Thus, the barriers between universes are not only limits, they are provocations. They tell us where the mystery lies. They remind us that even if the multiverse is forever beyond our grasp, the act of contemplating it changes how we see our own universe. It shifts the question from whether we can leave to what leaving would even mean. And in that shift, we find new horizons of thought, even if not of space. The barriers between universes confront us with a paradox. On one hand, physics points toward possibilities beyond our own cosmos. Bubbles from inflation, branches from quantum events, landscapes from string theory. On the other hand, those same theories suggest that the barriers dividing us from those realms are absolute. The other universes may exist, but they may be forever unreachable, sealed away not by distance, but by principle. This tension is what makes the multiverse at once thrilling and unsettling. It offers infinity, but denies us entry. Yet even impossibility has its fascination. We are compelled to imagine what it would mean to cross those barriers, even when reason says no. This is the birthplace of science fiction. Stories of travelers stepping through shimmering membranes or passing into parallel worlds are not predictions of technology, but metaphors for the hunger to escape boundaries. They give shape to a desire that physics alone cannot satisfy. Fiction builds doors where theory builds walls, and in doing so, it keeps alive the sense that reality is larger than what we see. This imaginative impulse is not wasted. By dreaming of crossing barriers, we explore what those barriers are. A novel may describe a passage between quantum branches, but in doing so, it forces us to ask why the branches are non-communicating. A film may picture a collision between bubble universes, but this invites us to consider what imprint such a collision would leave on the cosmic microwave background. Even the most speculative stories can sharpen real questions, pointing science toward the edges of the possible. There is also a philosophical lesson in these barriers. They show us that existence is not a single, seamless fabric, but may be divided into domains with no communication. This challenges our deepest intuitions about reality. We're used to thinking that if something exists, it must in principle be knowable, reachable, part of the same world. The barriers suggest otherwise. They suggest that existence may be broader than knowledge, that reality may contain regions forever beyond reason's grasp. To accept this is difficult, for it means giving up the dream of total understanding. But it may also be liberating, for it means the cosmos is inexhaustible. If barriers between universes are absolute, then leaving our universe in the literal sense is impossible. But perhaps the act of imagining escape is itself a kind of transcendence. We may not walk into another bubble or another branch, but by conceiving them, we expand our mental universe. The boundaries of thought are stretched, even if the boundaries of physics are not. The dream of leaving teaches us something about ourselves, that we are restless beings, always reaching beyond what is given, always pressing against horizons, even when they are unbreakable. And so the barriers stand, perhaps eternal. They are gulfs of inflation, partitions of quantum logic, architectures of string geometry. They are written into the structure of reality, forbidding passage. Yet, they are also thresholds of imagination, inspiring us to envision what lies beyond. To live with them is to live with the knowledge that the universe may not be all, and that what lies beyond may never be ours. But if we cannot leave in fact, we can leave in thought. The human mind is itself a kind of wormhole, carrying us into realms unseen. Fiction, philosophy, and speculation are bridges where physics builds walls. The barriers remain, but we do not stand idle before them. We imagine, and in that act we cross into new territory, even if only in the landscape of the mind. Thus, the barriers between universes are both the end and the beginning. They are the end of literal escape, but the beginning of a larger vision of reality, and they lead us naturally to the next question. If we cannot cross into other universes, can we at least imagine scenarios in which we might escape our own? If the cosmos itself has an ending, might there be ways to slip free before that end arrives? It is to these cosmic escape scenarios, both terrifying and profound, that we must now turn. The universe is not eternal in the way ancient philosophers once imagined. It has a history, a beginning in the Big Bang, and physics suggests it may also have an ending. To speak of leaving the universe in the literal sense may be impossible, yet the question takes on a new form when we ask what happens at the end of time. If the cosmos faces doom, is there any way to escape its fate? Could an advanced civilization outlast the universe, or even slip free from its collapse? These questions lead us into the realm of cosmic escape scenarios, where science meets speculation, and where the imagination grapples with the end of everything. One possibility is the Big Rip, a fate driven by dark energy. We know that the expansion of the universe is accelerating, carried by a mysterious force that makes up about 70% of the cosmos. If this acceleration grows stronger over time, the expansion will not simply continue, it will tear apart the fabric of reality. First, galaxies will drift beyond reach, then stars will be ripped from galaxies, then planets from stars, and finally, atoms themselves will be torn apart by the stretching of space-time. In the final moments, even subatomic particles will be destroyed. The universe will not end in a collapse, but in dismemberment. In such a scenario, there is no refuge. The very forces that hold matter together would fail. No starship, no wormhole, no bubble of shielding could survive the disintegration. Escape would mean leaving the universe entirely, for the universe itself would cease to be coherent. The Big Rip is a reminder that the laws of physics can turn not only into boundaries, but into executioners, dismantling the very structures they once built. Another fate is the heat death of the universe, the slow fading into darkness. In this picture, the cosmos continues to expand forever, but its energy becomes thinly spread. Stars exhaust their fuel, galaxies dim, black holes slowly evaporate through Hawking radiation. Over unimaginable spans of time, 10 to the power of 100 years and beyond, matter itself decays, leaving a thin soup of particles drifting in near absolute darkness. The universe does not end in violence, but in silence, a graveyard of extinguished light. Could any form of life endure such a future? Some have speculated that advanced civilizations might slow their metabolism, living in bursts separated by long pauses, stretching finite energy across infinite time. Others imagine harvesting energy from black hole evaporation or quantum fluctuations, eking out survival on the thinnest trickles. But even these strategies fail as entropy grows. Eventually, the heat death erases not only life but the very possibility of thought. Escape from heat death would require not only technology but an exit from the universe itself. There is also the scenario of a big crunch, in which dark energy reverses sign or expansion slows, leading the universe to collapse back upon itself. Galaxies would fall inward, stars would collide, temperatures would soar, and the cosmos would shrink toward a fiery singularity. In such a universe, the end resembles the beginning, a return to density and heat. Some theories suggest that from this collapse, a new universe might emerge, a cycle of bangs and crunches repeating endlessly. If so, perhaps leaving one collapsing universe might mean being born into another. Yet for beings within, the collapse would be inescapable. The universe would end by devouring itself, carrying everything within into oblivion. Even more dramatic is the possibility of vacuum decay. Quantum field theory suggests that our universe may not be in the lowest possible energy state, but in a false vacuum. If a more stable state exists, then a bubble of true vacuum could form spontaneously. Expanding at nearly the speed of light, it would erase the laws of physics as we know them, rewriting reality with new constants and new particles. Such a transition would be instant and unstoppable. There would be no warning, no survival, no escape. The barrier here is not distance, but definition. The universe itself would become something else, and we would vanish with it. Each of these scenarios paints a picture of the end, and each shows that escape is not a matter of distance or speed. It is a matter of redefining existence. If the universe ends in heat death, escape means leaving entropy. If it ends in a crunch, escape means leaving collapse. If it ends in vacuum decay, escape means leaving physics itself. These are not journeys any spacecraft could make. They are transformations in the deepest sense, and perhaps they are impossible. And yet, the idea of cosmic escape endures. It endures because we are unwilling to accept that existence itself has a final limit. It endures because to imagine leaving the universe is to imagine transcending death on the largest possible scale. Whether achievable or not, the thought keeps alive the human refusal to surrender. And in that refusal lies the seed of our next inquiry. If leaving is impossible in practice, could it be possible in principle? Could there be ways, hidden in the laws of physics, to cheat fate and outlast the end of time? The idea of cosmic escape is shaped by the tension between inevitability and imagination. On one side stand the cold predictions of physics, which tell us that every star will burn out, every galaxy will drift away, every black hole will evaporate. On the other side stands the human refusal to accept finality. Even when faced with the collapse of the universe itself, we wonder, is there a way out? Could intelligence find a loophole in the laws of nature, a passage beyond doom? Consider again the heat death. The universe in this state would be vast, dark, and nearly uniform. Entropy would be maximized, meaning energy could no longer be used to perform work. No engines would turn, no lights would shine, no thoughts would spark. And yet, thinkers such as Freeman Dyson once speculated about ways life might persist. Perhaps civilizations could learn to slow their processes, living in cycles of activity and dormancy. Perhaps they could extract energy from ever rarer sources, stretching survival indefinitely. Though later studies cast doubt on these strategies, the exercise reveals something vital. That even in the face of ultimate entropy, we imagine survival. The Big Rip, by contrast, offers no such mercy. If dark energy grows stronger with time, expansion will accelerate until it overwhelms every force. Galaxies will be torn apart, stars ripped from planets, planets from their cores, atoms from their electrons, and finally, space itself will be shredded. This is destruction not by entropy, but by expansion itself. The universe ends not with a whimper, but with a scream, every bond undone. In such a fate, escape would require leaving space-time before the tearing begins. Nothing bound by the laws of this cosmos could survive. The only refuge would lie in another universe if such a place could be reached. The Big Crunch, while violent, offers a different vision. Here, the universe does not stretch forever, but collapses inward. Over billions of years, galaxies fall together, radiation grows hotter, and density rises until everything is crushed into a singularity. The cosmos becomes a furnace consuming itself. But from this destruction, some theories imagine rebirth. Perhaps the singularity that ends one universe becomes the Big Bang of another, in an endless cycle of cosmic phoenixes rising from their ashes. If so, then escape might not mean leaving the universe, but enduring into its rebirth. Civilizations might dream of surviving across cycles, passing information from one cosmos to the next, leaving messages encoded in the fabric of physics. Vacuum decay is the most chilling possibility. If our universe is a false vacuum, then at any moment, without warning, it could transition to a true vacuum. A bubble of new physics would appear and expand at nearly the speed of light, erasing everything in its path. Chemistry, matter, even the forces that bind existence would be rewritten. No preparation would help, for the change would arrive faster than any signal. From our perspective, the universe would simply vanish. Escape in this scenario is meaningless. There is nowhere to go, nothing to do. It is pure erasure. Despite these grim scenarios, the thought of cosmic escape persists. We imagine civilizations far beyond us, capable of manipulating black holes, harnessing dark energy, or even creating new universes. Perhaps they could build a refuge against entropy or leap through a wormhole into a fresh cosmos. Perhaps they could seed baby universes, carrying life into new domains when this one fails. These ideas stretch physics to its breaking point, but they are not mere fantasy. They are the natural extension of the same curiosity that once asked if we could fly, or if we could leave the Earth. What unites these scenarios is the recognition that leaving the universe is not like leaving a planet or a star. It is not a matter of crossing distance. It is a matter of escaping fate itself. Each cosmic ending, heat death, big rip, big crunch, vacuum decay, represents a cage of different design. To imagine escape is to imagine slipping through the bars of time, energy, and physics themselves. It is to imagine that intelligence, by knowing the laws, might someday step beyond them. And so, even as the universe confronts us with endings, the mind insists on asking about exits. The answers may be impossible, the laws may be absolute, but the act of asking is itself a kind of escape, a refusal to be confined by doom. In contemplating cosmic escape, we reveal not only the destiny of the universe but the nature of the human spirit. Restless, imaginative, and unwilling to accept that even eternity must be final. The fate of the universe may be written in the equations of physics, but the possibility of escape lingers in the imagination. It is tempting to think of doom as a story with a clear ending, but perhaps endings themselves are illusions. Just as horizons are not walls, the death of the cosmos may not be the end of all existence, only the end of this chapter. What follows may be inaccessible, or it may hold new beginnings. To consider escape is to consider not only what could be done in practice, but what it means to exist when existence itself is at risk. Take the long view of heat death. After stars fade and galaxies dissolve, black holes remain as the last engines of the cosmos. They will evaporate slowly, over timescales so vast that the mind struggles to grasp them. When the last black hole fades, the universe will be dark. Yet some theorists suggest that even in this darkness, quantum fluctuations may still spark brief structures, momentary bubbles of order. Could life arise again in such rare sparks, or could intelligence find a way to sustain itself in this fluctuating sea? The odds seem slim, but the question itself shows how persistence of thought outlasts certainty of fate. In the Big Rip, destruction comes not slowly but swiftly. If dark energy grows ever stronger, the final moments would arrive in a storm of tearing. Planets shredded, atoms undone, space-time itself ruptured. There is no hiding from such a fate. Yet even here, the imagination searches for escape. Could a civilization detect the approach of the rip and create a new pocket universe before the final tearing? Could they step sideways into a cosmos where dark energy behaves differently? Such ideas stretch far beyond the reach of science, but they embody the refusal to yield, the insistence that there must always be another door. The Big Crunch, though violent, contains the seed of hope in its very nature. If collapse leads to a new Big Bang, then perhaps universes are reborn eternally. If so, then survival might mean finding a way to carry information from one cycle to the next. A civilization advanced beyond our imagining might encode knowledge in patterns of fundamental constants, seeding each new cosmos with traces of its predecessor. In this way, escape would not be physical but informational, a passage not of bodies but of memory. To endure across cycles would be to transcend mortality on a cosmic scale. Vacuum decay offers no mercy, no warning, no path. If a true vacuum bubble forms, it will erase everything in an instant. But even this terrifying prospect carries a strange beauty, for in a sense, we would not suffer it. The bubble travels at light speed, faster than any perception. One instant the universe is, the next it is gone. To us there would be no end at all, only being and then non-being. Escape here is inconceivable, and yet the thought of it reminds us of the fragility of reality, the precarious balance of laws upon which existence rests. What all these scenarios share is a confrontation with finality. They tell us that the universe is not a permanent home, but a temporary stage. And they force us to ask, what does it mean to leave? Is escape physical, a movement into another cosmos? Is it informational, a passing of knowledge from cycle to cycle? Is it philosophical, the act of imagining beyond endings, even when no exit exists? Each answer expands our understanding, even when the barriers remain absolute. Thus, cosmic escape scenarios are not merely doomsday visions, they are exercises in transcendence. They push us to imagine survival where none seems possible, to dream of continuities that outlast collapse, to conceive of exits from prisons built by physics itself. Whether possible or not, they remind us that intelligence does not stop at the walls of fate. It presses beyond, always seeking the door in the dark. And so, even as the universe confronts us with rips, deaths, crunches, and decay, we do not surrender to silence. We imagine escape. And in that act, we achieve a kind of escape already, not from the cosmos, but from the despair of inevitability. For to ask how to leave is to affirm that existence is never closed, that there is always a beyond, even if that beyond exists only in thought. With this in mind, we turn to the boldest speculation of all. Could we, instead of leaving the universe, one day create a new one? To imagine leaving the universe is daunting enough, but an even more radical idea suggests itself. Perhaps instead of leaving, we could create. What if an advanced civilization could give birth to a new universe, a cosmos that blossoms from the old, carrying with it a fresh beginning? This speculation blurs the line between physics and philosophy, between science and myth, but it is grounded in real questions about the nature of space-time. If universes can emerge from singularities, and if our own universe began as such, then might it be possible to spark a new one under the right conditions? Some physicists have proposed that black holes may be seeds of universes. Inside a black hole, matter collapses toward a singularity, a region where density and curvature become infinite in Einstein's equations. To an outside observer, this singularity is hidden behind the event horizon, unreachable by light. But some solutions to general relativity suggest that what looks like an end from our perspective might be a beginning from another. A singularity might give rise to a new expanding region of space-time, disconnected from ours, a universe budding off from the collapse of matter. If so, then every black hole could be a portal to another cosmos. Each time a massive star dies and collapses, a new universe may be born beyond its horizon, invisible to us but real in its own domain. We cannot see inside to confirm this, but the mathematics allows the possibility. Our own universe may have been born this way, from a black hole in some parent cosmos. If true, then creation is not a unique event, but a repeating process. Universes giving rise to universes in an endless branching tree. The idea that civilizations might harness this process is both astonishing and unsettling. If one could manipulate matter and energy, at the scales required? Could they create a black hole that seeds a new universe? And if so, could they shape the conditions of that new cosmos, setting its constants of nature, its laws of physics, its potential for life? In this vision, creation becomes not only a cosmic process, but an act of engineering. Universes would not only exist, they could be designed. Of course, the barriers to such creation are immense. We do not yet understand the true nature of singularities. General relativity predicts them, but quantum mechanics must alter the picture at extreme scales. A full theory of quantum gravity, still elusive, would be needed to know whether universe creation is possible. And even if it were, the energy requirements would be beyond anything our species could imagine. Creating a black hole large enough to be stable would require compressing mass comparable to stars or greater. For now, the notion is far beyond reach, but the philosophical implications are too great to ignore. If universes can be born from other universes, then the chain of creation may be infinite. There may be no ultimate beginning, only a branching tree of cosmoses. And if advanced civilizations can learn to shape this process, then perhaps universes themselves are products not only of physics, but of intelligence. Our own universe might carry the fingerprints of creators, beings from a parent cosmos, who seeded it with conditions favorable for complexity. This is speculation, but it blurs lines we once thought fixed. The question shifts from, can we leave the universe, to what counts as leaving? If a civilization creates a new cosmos, have they escaped their own, or have they merely extended it? If they pass into the baby universe they seeded, would that be a form of departure? Or is it reproduction rather than escape, a continuity of existence rather than a departure from it? The universe in a lab is not only a scientific question, but a mirror to our own longings. It reflects our refusal to be trapped, our desire to transcend boundaries, our wish to play a role in creation itself. It asks whether intelligence, in the end, can rise to the level of cosmic architect, shaping not only planets and stars, but existence itself. Whether or not it is ever possible, the thought changes how we see ourselves, not as inhabitants of the cosmos, but as potential creators of new ones. And so, the idea of a universe in a lab carries us to the threshold of philosophy. It tells us that to leave the universe may not be to walk out of it, but to grow beyond it. It tells us that the boundaries between science and myth, between physics and meaning, are not as firm as we imagine. And it prepares us for the next step in our journey, to ask what it means, philosophically, to speak of leaving the universe, and whether such language itself creates paradoxes deeper than physics can resolve. The notion of creating a universe in a laboratory stretches the imagination in ways few scientific ideas can. On one hand, it emerges naturally from the mathematics of black holes and cosmology. On the other, it feels like something out of myth, echoing ancient stories of gods who fashioned worlds from chaos. The difference is that here the creators are not divine, but technological, beings who have mastered the laws of physics so completely that they can use them to spark reality itself. Some models of cosmology suggest that a baby universe could be formed if enough energy were compressed into a small region. In such a state, the energy density might become high enough to trigger inflation, the runaway expansion that shaped our own cosmos in its first instant. Once begun, inflation would carry the baby universe away, expanding faster than light, cutting it off from its parent. From the inside, it would appear as a vast and growing cosmos. From the outside, it would look like nothing more than a microscopic bubble, unreachable and disconnected. This raises a strange possibility. If baby universes can form, then they may already be budding constantly in regions of space-time beyond our reach. They may be sprouting like seeds in a vast forest, each one becoming its own self-contained reality. Our universe could itself be a bubble born in such a process, the child of another cosmos. If so, then creation is not an event, but a continuum, an unending fertility of existence. But if an advanced civilization could initiate such a process deliberately, what would it mean for them? Would they be able to influence the constants of the new universe, shaping its physics? Could they select conditions that favor the emergence of complexity, stars, and life? If so, then perhaps universes evolve not only by chance, but by design. Perhaps those universes that give rise to intelligent beings capable of creating new universes will themselves produce offspring, a kind of cosmic natural selection. Over time, universes favorable to complexity would multiply, while sterile universes would fade. In this way, life and intelligence would not only be products of the cosmos, but participants in its reproduction. The implications of this idea are staggering. If our universe was shaped by such a process, then its apparent fine-tuning for life may not be a coincidence at all. It may be the inheritance of choices made in a parent cosmos, where beings sought to preserve their legacy by creating universes like their own. In this view, we are part of a lineage, descended not only from stars and galaxies, but from universes themselves. The chain of creation would be endless, a cosmic genealogy stretching back beyond comprehension. Of course, this remains speculation. We do not yet know whether baby universes can be created, let alone shaped. But the very act of considering it forces us to rethink what we mean by leaving. If we cannot step into another universe, perhaps we can give rise to one. If we cannot cross the barriers, perhaps we can build new territory on the other side. The distinction between escape and creation begins to blur. To leave may mean to seed, to create a continuity beyond our own existence. This possibility also reframes the question of survival. If our universe faces heat death, big rip, or vacuum decay, then perhaps the ultimate escape is not to flee, but to give birth. A civilization might not outlast its cosmos, but it might leave descendants in the form of universes. They would never know their creators, and we would never see them, but the chain of being would continue. Life would persist, not within our universe, but beyond it, in universes we set in motion. And so the idea of a universe in a lab is more than speculation. It is a metaphor for hope in the face of inevitability. It says that even if we cannot escape, we can continue. Even if we cannot survive, we can seed. Even if the universe itself must end, existence may not end with it. Creation becomes the ultimate act of transcendence, a way of stepping beyond boundaries by ensuring that boundaries themselves give way to new beginnings. This vision is breathtaking, but it also leads to a deeper question. If universes can be created, and if our own may be the product of such creation, then what does it mean to speak of the universe at all? Are we still speaking of everything that exists, or only of one link in an infinite chain? The word universe begins to fray under the weight of these possibilities, preparing us for the next stage of our inquiry. Not how to create or leave universes, but what it means to speak of them in the first place. The image of a universe born in a laboratory forces us to confront the limits of our language. For centuries, the universe has meant everything, the totality of being. But if universes can be created, then the word no longer describes a singular totality. It becomes a category, one among many, each with its own laws, its own birth and its own destiny. To speak of the universe in a lab is to admit that the cosmos may not be one, but many, not eternal, but generative. If such creation is possible, then the act itself raises profound questions about responsibility. Suppose an advanced civilization reaches the point where it can seed a new cosmos. By doing so, They would shape the fate of uncountable stars and galaxies, perhaps even the possibility of life. Do they bear responsibility for what unfolds inside? Or is the new universe entirely separate, its contents beyond the reach of its creators? The question is more than hypothetical. It touches on the ethics of creation itself. If universes can be engineered, then the act of creation becomes the most consequential decision imaginable. The concept also unsettles our sense of meaning. If universes can be born endlessly, then what is special about ours? Perhaps it is simply one among countless others, no more unique than a drop in a waterfall. Or perhaps it carries within it the imprint of a design, the echo of choices made in a parent cosmos. If so, then our existence is not an accident of chance, but a continuation of intention. We might be part of a chain of purpose stretching back through realities, even if we can never know the creators who came before. Some thinkers suggest that if universes can be seeded, then natural selection may act at the cosmic scale. Universes capable of giving rise to life and intelligence will also give rise to new universes, passing along traits that favor complexity. Over time, these universes will dominate, while sterile ones will vanish. This is not selection by biology, but by physics, a kind of cosmic evolution. If so, then our existence is not only possible, but inevitable. Life is not an accident, but the engine of continuation, the means by which universes reproduce. Speculation of this kind may never be confirmed. We cannot observe other universes directly, nor can we step into one we might create. But the very thought reshapes our perspective. To imagine a universe in a lab is to imagine that intelligence is not merely a product of the cosmos, but a participant in its unfolding. It suggests that the story of the universe is not only physical, but creative, that existence is not a closed circle, but an open chain. This brings us to the paradox at the heart of the idea. If a civilization were to create a new universe, would that count as leaving their own? In one sense, no, for they would remain within their cosmos, bounded by its fate. In another sense, yes, for they would have extended their reach into a new domain, one that continues when theirs ends. Escape, in this vision, is not a matter of stepping through a door, but of planting a seed, not departure, but legacy. And so, the image of a universe in a lab is both science and parable. It is science because it arises from real questions about singularities, black holes, and inflation. It is parable because it reflects our deepest longing, the refusal to end, the desire to continue beyond endings, the dream of transcendence through creation. Whether possible or not, the thought changes us. It expands what we mean by universe, what we mean by escape, and what we mean by existence itself. Thus, as we close this chapter, we find ourselves at the edge not of physics, but of philosophy. The word universe, once a synonym for all, now trembles under the weight of possibility. If there are many universes, if they can be born, if they can even be shaped, then what does it mean to leave, to enter, to exist? These questions cannot be answered by equations alone. They belong to a deeper inquiry, one that asks not only about what is, but about what it means to speak of it. And so we turn to the philosophical edge, where language, logic, and longing converge, and where the universe itself becomes an idea to be questioned. If the universe is everything, then by definition, we cannot leave it. To leave implies stepping outside, but if there is no outside, the very question collapses. This is the paradox at the heart of our inquiry. For thousands of years, thinkers have wrestled with the meaning of the word universe and with the limits of language itself. Science gives us equations, but those equations must be framed in words, and words sometimes trap us in illusions. The universe is not a house with walls, yet our minds insist on imagining it that way because language was born for smaller things. When we say universe, we often mean different things. Sometimes it means the observable universe, the sphere of space and time from which light has had time to reach us. Sometimes it means the entire cosmos, including the regions forever beyond our horizon. And sometimes it means the totality of all existence, including other universes if they exist. Each definition is valid, but each leads to different answers. To leave the observable universe is impossible in practice, because of horizons and expansion. To leave the entire cosmos is impossible in principle, because there is no beyond in the framework of relativity. To leave existence itself is incoherent, because leaving would mean stepping into non-existence, which is not a place but an absence. This is where philosophy becomes indispensable. Physics tells us what is possible, but philosophy reminds us to examine what we mean when we speak of possibility. To ask if we can leave the universe may be to misuse the word leave. It may be like asking what lies north of the North Pole. The question carries a sense of direction, but no direction exists. And yet, paradoxical as it may be, such questions are not empty. They reveal the limits of language and the shape of thought. By pressing against those limits, we discover new ways of seeing. Philosophy also forces us to consider the meaning of multiverse. If other universes exist, then the word universe no longer means everything. It becomes a subset, one domain in a larger reality. But what do we call that larger reality? Some speak of the multiverse, but this term is itself paradoxical, for it suggests many alls. If universe once meant totality, then many universes implies many totalities, which is a contradiction in terms. And yet, the mathematics of inflation, quantum theory, and string theory suggest just that. Language strains to contain what thought discovers. The paradox deepens when we reflect on our need for transcendence. We ask about leaving the universe not only as a scientific curiosity, but as an existential longing. We seek to escape boundaries because boundaries remind us of mortality. The horizon is a symbol of death, the point beyond which we cannot go. To imagine leaving the universe is to imagine escaping death itself, to imagine that existence has a beyond into which we might step. It is not only cosmology, but psychology, not only physics, but yearning. This is why science fiction resonates so strongly with the theme. When stories show characters passing into parallel worlds or traveling to dimensions beyond, they are dramatizing this longing. The physics may be speculative, but the desire is real. The philosophical edge is not about whether wormholes exist or whether universes collide. It is about what it means to be human in a cosmos that seems bounded, and to imagine freedom from those bounds. At this edge, physics and philosophy intertwine. Physics tells us the rules. Philosophy asks what the rules mean. Physics tells us that light speed is a limit, that horizons are absolute, that leaving existence is incoherent. Philosophy asks why these concepts unsettle us, why we resist them, why we keep imagining beyond them. In this interplay lies the deepest value of the question. We may never leave the universe in fact, but in asking, we expand the boundaries of thought. Thus, the philosophical edge is not the end of our inquiry, but the beginning of a deeper one. To ask whether we can leave the universe is to confront the limits of words, the paradoxes of definition, and the nature of longing. It is to discover that sometimes the most profound answers are not found in equations, but in the act of questioning itself. And so, as we stand at this edge, we prepare to look once more toward the horizon, knowing that even if we cannot cross it, the act of reaching changes what it means to be. The philosophical edge grows sharper when we confront the problem of definition. If universe means everything, then asking about leaving it is meaningless. But if we allow the possibility of a multiverse, then universe means only one among many, and leaving becomes conceivable. This shows that our deepest questions depend on the way we frame them. Words guide thought, and thought shapes possibility. The danger is that we confuse the limits of language with the limits of reality. Philosophers have long warned of this trap. Ludwig Wittgenstein argued that many puzzles arise because words are stretched beyond their proper use. To ask what lies outside existence may be such a puzzle. Outside is a spatial metaphor. Existence is not a spatial thing, and combining them yields nonsense. Yet our minds are drawn to such nonsense because we crave direction and context. We want to imagine a beyond, even when none is possible. The philosophical edge is where this craving collides with logic. And yet, there is another way to look at it. Perhaps questions that seem meaningless within one framework become meaningful within another. For the ancient Greeks, to ask what lay beyond the heavens was meaningless, because the heavens were everything. For us, the heavens are only part of the cosmos, and the question of what lies beyond has become astronomy. Could it be that what seems paradoxical today may one day be reframed, not as nonsense, but as science? Could the idea of leaving the universe be one of those questions whose meaning evolves as knowledge grows? Consider how the concept of horizon has changed. Once it meant the line where the sky meets the earth, a simple boundary of vision. Now it means the edge of space-time itself, the limit of what can ever be seen. In the same way, leaving the universe may not mean stepping into a physical outside, but transcending some boundary we do not yet understand. It may mean moving into another domain of being, not in space, but in concept. Perhaps the act of asking is a rehearsal for insights not yet possible. This leads to the deeper paradox. We cannot leave the universe if it is all that exists, and yet the very act of asking how shapes our sense of existence. To ask what lies beyond is to acknowledge the incompleteness of our understanding. It is to confess that reality may be larger than our definitions. This confession is powerful. It keeps curiosity alive, even when answers are denied. It makes the universe not smaller, but larger, because it admits the possibility of more. Here, the philosophical edge meets the human condition. We are finite beings in an infinite-seeming cosmos. We live short lives under long stars, aware of our limits, yet yearning to surpass them. To ask about leaving the universe is to express this yearning at its grandest scale. It is a cosmic version of the same impulse that drives us to cross oceans, to climb mountains, to build rockets. It is the refusal to stay within boundaries, the insistence on looking beyond. Philosophy reminds us that the question is not foolish, even if the answer is paradox. Questions reveal the shape of thought, and thought reveals the shape of longing. When we ask whether we can leave the universe, we are not only probing physics, but expressing who we are. We are beings who imagine more than we can see, who resist finality, who dream of horizons that cannot be crossed. Thus, the philosophical edge is not a place of despair, but of discovery. It shows us that boundaries are as much in language as in reality, and that pressing against them expands both. Whether the multiverse is real or not, whether escape is possible or not, the act of asking changes us. It widens the field of vision, deepens the sense of wonder, and prepares the way for new forms of understanding. And so, the question of leaving the universe becomes less about physics and more about philosophy. It becomes a mirror in which we see our own restlessness reflected. It becomes a path along which thought travels, even when feet cannot. It becomes a reminder that the greatest journeys are not always through space, but through the imagination itself. At the philosophical edge, the question of leaving the universe dissolves into paradox. If universe means all that exists, then departure is impossible. If it means only what we can observe, then leaving is merely travel into regions forever hidden by horizons. If it means one cosmos among many in a multiverse, then leaving could mean crossing into another domain, though we do not know how. The question shifts depending on the definition, and in shifting, it reveals that we are not only exploring physics, but testing the limits of thought itself. This tension reflects the way human beings confront boundaries. We do not accept them as final. We probe them, question them, and imagine beyond them. The boundary of death gave rise to religion, myth, and philosophy. The boundary of Earth gave rise to exploration and science. The boundary of the universe itself gives rise to cosmology and speculation. To ask about leaving the universe is to enact the same drama at the grandest scale, the refusal to believe that any wall is absolute. And yet, philosophy warns us of hubris. Not all questions admit of answers, and not all boundaries can be crossed. It may be that the question of leaving the universe is incoherent, like asking to step outside time. But incoherent does not mean useless. It forces us to examine the assumptions hidden in our words. It forces us to see that universe, existence, and beyond are not fixed concepts, but shifting frames. In asking the impossible, we learn what is possible. Some philosophers argue that the very act of imagining other universes already counts as leaving in a sense. The mind has crossed into a realm beyond its home, constructing models of existence that may or may not be real. Thought becomes the escape, imagination the doorway. We cannot step physically into another cosmos, but in conceiving of one, we transcend the limits of our own. This is not science in the empirical sense, but it is a form of exploration, and it carries its own value. Others take a more skeptical view. They warn that talk of multiverses and leaving the universe risks sliding into metaphysics or fantasy. Without evidence, they argue, such speculation tells us more about human longing than about reality. But even this skepticism acknowledges the power of the question. Longing itself is a fact, as real as stars. The desire to leave the universe is not a scientific result, but it is a truth about human nature. And truths about nature include not only matter and energy, but the minds that question them. In this way, the philosophical edge reveals itself as both limit and mirror. It is the place where the universe resists us, refusing to yield further answers. And it is the place where we see ourselves reflected, restless, questioning, never satisfied. It is the place where science becomes philosophy, and philosophy becomes poetry, because words and equations alike are stretched to their breaking point. The paradox remains unresolved. Perhaps it always will. But that is not failure. It is the essence of wonder. To stand at the edge of what can be known and still ask what lies beyond is to be human. To insist on leaving even when there is no outside is to affirm that imagination is itself a kind of transcendence. We may never cross a barrier into another cosmos, but in the act of asking, we step beyond the limits of our own. Thus, the philosophical edge is not the end of the journey, but its culmination. It shows us that the question, could we ever leave the universe, is not only about physics, but about the human spirit. And it prepares us for the final horizon, where science and philosophy meet, and where the act of questioning becomes the ultimate form of escape. We have followed the question of leaving the universe across science, speculation, and philosophy. We have traced horizons and wormholes, multiverses and barriers, doomsday scenarios, and the dream of creating new universes. Each step has shown us limits, and each limit has pushed us deeper into wonder. Now, at the end of our journey, we must ask what remains beyond the final horizon. If physics denies us escape, if philosophy denies us coherence, is there still something to be found in the act of asking? Science today offers no path to leaving the universe. The speed of light fixes a boundary on travel. The cosmic horizon hides most of existence. General relativity forbids an outside. quantum mechanics seals its many branches against crossing. String theory's landscape is vast but disconnected. Every scenario we imagine ends in impossibility. Yet impossibility itself is instructive. It tells us not only what we cannot do, but what reality is. Limits are not mere obstacles, they are features of the cosmos as real as stars. And still, the human spirit refuses to stop at limits. Where physics places horizons, imagination builds bridges. Where philosophy finds paradox, poetry finds meaning. The dream of leaving the universe persists, not because it is possible, but because it expresses something fundamental: the refusal to accept boundaries as final. It is the same impulse that drove us from caves to continents, from Earth to orbit, from ignorance to knowledge. To ask what lies beyond is to continue that journey, even when the answer is silence. At the final horizon, science and philosophy converge. Science tells us what is, philosophy tells us what it means, and both tell us that the universe is larger than our grasp. Whether or not there are other universes, whether or not escape is possible, the act of asking reshapes our understanding. It turns the universe from a prison into a mystery, from a closed system into an open question. The final horizon is not a wall, but a mirror, showing us our own restlessness reflected in the cosmos. Perhaps we cannot leave the universe. Perhaps we are bound within it, as fish are bound within the sea. But even fish dream of the air, and in dreaming, they change their relation to the water. We too change our relation to the cosmos by imagining beyond it. We learn that existence is not only what can be measured, but also what can be imagined. We learn that the final frontier is not space, but thought. In this sense, we have already stepped beyond. Not in rockets or wormholes, not in physics or engineering, but in imagination. The question of leaving the universe has carried us across horizons of knowledge, into landscapes of speculation, and to the edge of philosophy itself. At each step, we have left something behind: the comfort of certainty, the simplicity of definitions, the illusion of finality. What remains is wonder, the endless horizon of thought. And so, our journey ends where it began, with a question. Could we ever leave the universe? Science says no. Philosophy says the question itself may be flawed. But imagination says yes, always yes, because imagination is the one thing that crosses every boundary. To ask is already to leave. To imagine is already to step beyond. Perhaps we cannot leave the universe, in fact, but in asking how, we have already traveled farther than the horizon allows, into a realm no equation can forbid. The closer we draw to the idea of a final horizon, the more we realize that leaving the universe may never have been the true question. Beneath the physics, the paradoxes, and the speculations lies something older and more human: the desire to transcend. We want to outlive boundaries, to find meaning beyond endings, to touch what lies outside of time and space. The cosmos resists us with limits, but limits are the very things that ignite imagination. The scientific story is clear enough. The speed of light keeps us bound to our corner of space-time. Expansion carries galaxies beyond our reach. Black holes hide their secrets behind horizons we cannot cross. The quantum world offers branching universes, but forbids communication between them. Each theory draws its line and says, "Here and no farther." Yet when faced with no farther, we have always asked, what if? It is this question that defines us more than any answer. Consider how far such questions have already carried us. Once, the sky was thought to be a dome with stars painted on it. To ask what lay beyond was meaningless. Then we learned the stars were suns, the galaxy was vast, and other galaxies stretched outward like an ocean without shore. Each time the horizon expanded, it did so because someone refused to accept it as final. To ask about leaving the universe is to continue this tradition, to keep the horizon from hardening into a wall. And even if we never leave, the question has consequences. It shapes how we see our place in existence. If the universe is all, then we are woven into its fabric, inseparable from its fate. If the multiverse is real, then we are one expression of a greater reality, not singular, but plural. If universes can be created, then perhaps existence itself is an ongoing act of creation, with intelligence as one of its tools. Each perspective transforms our sense of meaning, even if none grants us an exit. There is also a humility in facing the final horizon. To admit that we may never leave is to admit that reality is larger than us. It is to recognize that our role may not be to escape, but to witness, to understand, to ask. The universe may be closed to departure, but it is open to wonder. And wonder is its own kind of freedom, for it allows us to dwell within limits without being confined by them. Perhaps this is the true lesson of the final horizon. It is not a barrier to be crossed, but a mirror in which we see ourselves. The question of leaving reveals our restlessness, our refusal to stay bounded, our drive to imagine what lies beyond. We cannot leave the universe, but we can leave the narrowness of thought. We cannot escape entropy, but we can escape despair by transforming endings into questions. In this way, the final horizon is not the end, but the beginning of a deeper journey. It marks the point where science hands the question to philosophy, and philosophy hands it to imagination. It is the place where equations end and stories begin, where facts meet meaning, where curiosity becomes transcendence. To stand at this horizon is to recognize that even in the face of impossibility, we are not diminished. We are enlarged because we are capable of imagining what cannot be done. And so, beyond the final horizon, there may be no exit, no escape, no other universe waiting. But there is always the act of asking, always the power of thought, always the unending expansion of imagination. Perhaps this is the true way we leave the universe, not in ships or wormholes, not in physics or technology, but in the refusal to let limits be the last word. Beyond the final horizon lies silence, and in that silence we discover ourselves. We cannot leave the universe in any physical sense. Every path we have traced, wormholes, multiverses, baby universes, cosmic escapes, runs into walls of principle or impossibility. Yet to arrive here is not to end in despair. It is to understand that the journey was never about finding an exit, but about discovering the scope of our longing. The question, could we ever leave the universe, is answered not by science alone, but by the human spirit that insists on asking it. When we say universe, we mean more than physics. We mean the stage of all that is. And when we imagine leaving, we mean more than travel. We mean the hope that existence itself has room beyond its boundaries. That being is not closed but open, that there is always something more. The universe may deny us doors, but imagination builds them, and in building them, we are changed. Perhaps this is why the cosmos inspires awe, even in its indifference. The stars do not care whether we dream of escape, yet they are the canvas upon which we paint that dream. The laws of physics do not bend to our desires, yet our desires stretch beyond those laws. The final horizon is a limit in reality, but in thought it becomes a passage. It carries us into philosophy, into poetry, into questions about meaning that lie deeper than any telescope can reach. This is not to diminish science. On the contrary, it is science that brought us here, by showing us horizons, equations, and impossibilities. Without science, we would still believe the sky was a dome, the universe eternal, reality simple. With science, we see how vast, how strange, how complex it all is. Science shows us the limits, philosophy shows us their meaning. imagination shows us the way beyond. Together, they weave a story larger than any single perspective could hold. So the final answer may be this: no, we cannot leave the universe, but in asking how, we already transcend it. The question itself is the passage. To imagine wormholes, multiverses, baby universes, and cosmic fates is to step beyond the prison of the immediate. It is to live in the open space of possibility, even when possibility denies itself. We may be bound by light and entropy, but we are not bound in thought. Our minds cross horizons no physics can bar. Perhaps someday, if knowledge deepens and laws reveal hidden doors, we will discover a path no one today can imagine. Or perhaps not. Perhaps the walls are final, the boundaries absolute. Either way, the question endures, and in enduring, it reshapes us. For to ask about leaving the universe is to glimpse the scale of existence, to measure ourselves against infinity, to recognize that even if we cannot escape, we are part of something vast and mysterious beyond words. And so, the journey ends with a paradox and a promise. The paradox is that leaving the universe may be impossible, yet imagining it is unavoidable. The promise is that in imagination, we have already done it. Beyond the final horizon lies no other world, no secret cosmos, no waiting refuge. What lies beyond is the power of thought itself, the only true vehicle of transcendence. We may not leave the universe, but in daring to ask how, we step beyond the limits of what is, into the limitless expanse of what could be.